Welcome to the deep dive. Today we're gonna try to, really get to the bottom of this whole causality thing.
Hmm.
We've got some notes here that are kind of like Causality 101,
Mm.
and I think our mission today is to help you guys understand how people figure out what actually causes what.
It's a lot harder than you might think. A
Yeah.
lot of times we see two things happening together and we kind of just assume one causes the other.
Yeah.
But there's a whole science to like really teasing those relationships apart,
Yeah.
especially in fields like economics.
And that's what we're going to explore today. And, a lot of our notes focus on this idea of identification.
Hmm.
So, like, how do you actually pinpoint the true causal effect?
Yeah.
We're also going to learn about this cool visual tool called a DAG.
Right.
It's a directed acyclic graph.
Like a roadmap.
Oh,
But instead of streets, it shows us the different pathways of cause and effect.
I love that. Okay, so let's start with the basics. Our source material, they use some terms that maybe some of you aren't familiar with, things like estimand and estimate and identification. So
Yeah.
let's unpack those a little bit.
Yeah, imagine you're trying to figure out how much a new workout routine impacts weight loss.
Okay.
The amount of weight you would lose because of that routine, that's your estimate.
Okay.
It's the thing you're ultimately trying to measure.
Got it. So it's the target, the
Yeah.
thing we're trying to pin down.
Yep.
How do we actually measure that impact, though?
Well, that's where estimates and estimators come in.
Okay.
An estimator is kind of like the recipe or the formula that we apply to our data to get an estimate, which is our best guess at the true value of that estimate.
Hmm.
So it's like baking a cake.
Yeah.
You have a recipe, the estimator ingredients, the data, and you end up with a cake, which is the estimate.
So the estimate is like saying, I want to bake a chocolate cake.
Yes.
The estimator is the recipe,
Uh-huh.
and the estimate is the cake you pull out of the oven. Got it. Okay, now the challenge is, how do we know
Yeah.
if what we're measuring is truly a causal effect
Right.
or just a random correlation?
Exactly, because just because two things happen together doesn't mean one causes the other.
Right, exactly. Like,
Our notes use this fun example.
okay,
Imagine you're testing whether sleeping with your shoes on causes headaches.
okay,
You can't just look at people who wear shoes to bed and see if they get headaches,
right,
because there might be other things at play.
right. Like they were out partying all night,
Exactly.
and that's why they have a headache.
That's what we call a confounding variable,
Okay.
something that messes up our ability to see the true relationship.
So it's like a hidden
Yeah.
variable that we're not thinking about.
Yeah.
Okay. I'm starting to see how tricky this can get.
Mhm.
So how do researchers actually isolate a true causal effect?
Well, one way is through a randomized controlled trial or an RCT.
Okay.
It's like flipping a coin to decide who gets the new headache pill and who gets a sugar pill. This helps create two groups that are basically the same, except for whether they got the actual treatment.
Right. So you're trying to eliminate all those
Yeah,
confounding variables as much as possible.
exactly. But as our notes point out, RCTs aren't always possible.
Right.
Imagine trying to study the effect of speed limits on car accidents.
Hmm.
You can't just randomly change speed limits on different highways for the sake of research.
Yeah, that's true. So what do researchers do then when they can't run an RCT?
They look for what are called natural experiments.
Okay.
These are situations in the real world that kind of mimic the randomness of an RCT.
Hmm.
So, for example, maybe a few states change their speed limits,
Okay.
while others don't.
Hmm.
Researchers can then compare accident rates in those states before and after the change.
So they're kind of looking for something that's already happening in the
Yeah.
real world that they
Uh-huh.
can then use to study.
Exactly.
Okay, clever. But how do they make sure that they're not getting fooled by those confounding variables?
That's where identification comes in. And
Mm.
researchers use various techniques to isolate the true causal effect from the noise of those confounding variables.
So going back to our shoes and headaches example,
Yeah,
we'd want to control for the fact that maybe they were drinking the night before.
exactly.
Okay.
And that's where those DAGs I mentioned earlier come in.
Okay.
They can help us visualize these complex relationships.
Okay. Are you ready to jump into the world of DAGs?
Let's do it.
All right, let's do it. DAGs. All right. So tell me how these visual roadmaps can help us, make sense of causality.
So yeah, think of a DAG like a flowchart,
Okay.
but instead of steps in a process,
Okay.
we're looking at variables
Okay.
and how they might influence each other.
So in our shoes and headaches example, we might have one box that says shoes,
Uh-huh.
another box that says headaches, and another box that says drinking.
Exactly. And we'd connect those boxes with arrows to show the potential causal pathways.
Okay.
Like we might have an arrow going from drinking to shoes, because drinking might make someone more likely to fall asleep with their shoes on.
Right. And an arrow from drinking to headaches.
Exactly.
Because we all know what a hangover feels like.
Right now, here's where it gets interesting.
Okay.
By drawing out all these relationships,
Yeah.
we can start to identify what are called backdoor paths.
Backdoor path sounds sneaky.
They can be, backdoor path is an indirect route through which a confounding variable can mess with our results.
Mm.
So like in our example, the path from shoes to headaches through drinking is a backdoor path.
Because the drinking variable is influencing both whether someone wears shoes to bed
Yes.
and whether they get a headache.
Precisely. And DAGs help us see those backdoor paths
Right.
and figure out which variables we need to control for in our analysis.
Oh, so it's like putting up a roadblock
Exactly.
on those sneaky back roads to make sure we're only measuring the direct route.
Exactly. Let's walk through an example.
Okay.
Remember how we talked about RCTs? Our notes actually show how a DAG for an RCT of our shoes and headache question would be pretty straightforward.
Because in an RCT, we're randomly assigning people to wear shoes or not, so there's no confounding variables.
Right. The only arrow would go directly from shoes to headaches.
Got it.
Because that's the only relationship we're manipulating.
Yeah.
But in the real world, where we have things like drinking influencing both shoes and headaches,
Yeah.
the DAG gets more complex.
Okay.
We need to control for drinking
Right.
to block that backdoor path.
So it's like a cheat sheet.
That's a great way to think about
It's
it.
figuring out how to isolate that true causal effect.
Yeah, and DAGs can also help us see even more subtle relationships.
Oh.
Our source material introduced this concept of colliders.
Colliders are those like the opposite of backdoor paths?
In a way, yes. A collider is a variable that's influenced by both the potential cause and the potential effect we're studying.
Okay.
And this is where things get counterintuitive. Because sometimes controlling for a collider can actually create a false correlation.
Wait, so controlling for a variable can make things worse?
It can if that variable is a collider.
Hmm.
The example they use is fascinating. It's the relationship between the IQs of couples.
Okay.
Let's say we want to see if people with higher IQs tend to partner up with each other.
Okay.
Seems simple enough.
Yeah, we could just look at the IQs of a bunch of couples.
Yeah, but there's a catch. Their child's IQ.
Okay.
The child's IQ is influenced by both parents' IQs, making it a collider.
So if we try to control for the child's IQ,
Yes.
it's going to mess up our results.
Exactly. Imagine we look at couples who have a child with a high IQ.
Okay.
Now, if one parent have a high IQ, we might assume the other parent must have a lower IQ.
Right, to balance things out.
Yeah, but that might not be true at all.
So we're kind of forcing a negative correlation where one might not exist.
Precisely. The child's IQ is acting like a statistical magnet,
Huh.
pulling the parent's IQs toward the average when we control for it. That's collider bias in action.
Interesting.
You know, this reminds me of something I heard on another podcast.
Yeah.
They were talking about beauty and talent
Mm.
and how judging those two things together
Yeah.
can kind of create a similar misleading impression.
So it's not always obvious
No,
which variables we should or shouldn't control for.
that's right. And that's why DAGs are so helpful.
Yeah.
They can guide us through these complexities.
I like it.
Our source material wraps up with a great example of how to use a DAG to study the effects of medicine on headaches.
Sounds like something we can all relate to.
Yeah.
Let's dive into that example.
Okay, so they present this scenario where being sick causes both headaches and taking medicine.
Okay.
Rain can make you sick.
Right.
Drinking can cause headaches.
Mhm.
Being sick can lead to doctor visits.
Yeah.
And doctor visits can lead to taking medicine. It's a whole web of potential causal relationships.
Sounds complicated.
Yeah. But a DAG can help us visualize all of that
Right.
by mapping out all those variables and arrows.
Yeah.
We can see that there's a backdoor path from medicine to headaches through being sick
Okay.
to isolate the true effect of the medicine we need to control for sickness.
So our analysis would have to take into account whether someone was sick or not,
Exactly.
along with whether they took the medicine.
And the DAG helps us see that in this case, we don't need to control for things like rain
Okay.
or doctor visits.
Got it.
They might be related to headaches.
Yeah.
But they don't confound the specific relationship we're studying.
This is amazing. It feels like we're learning a whole new language
It is.
for understanding the world.
Yeah.
But I have to admit, it's a lot to take in.
It is. But the key is to start thinking about these concepts and how they might apply to your own areas of interest.
Mm.
Even a simple DAG can help you see things in a new light.
It's like we've been handed these like new lenses for seeing the world
Yeah.
that can filter out all these misleading correlations, and help us focus on the true relationships.
Yeah, that's a great way to put it. And the best part is this approach isn't just for researchers. Anyone can use it
Right.
to think more critically about the information they encounter.
So if I wanted to understand,
Yeah.
let's say, the impact of a new teaching method
Uh-huh.
on student performance, I could sketch out a DAG to help me think about all the confounding variables.
Absolutely. You could consider things like students' prior academic performance,
Mm,
their socioeconomic background,
yeah.
or even the quality of the school facilities.
Right.
A DAG can help you identify which of these factors you need to account for.
Wow. This has been such an eye-opening deep dive.
It has.
We started with some pretty technical terms,
Yeah.
but we ended up with this whole new way of thinking about cause and effect.
Yeah, it's pretty powerful stuff.
So as we wrap up, what's the key takeaway for our listeners?
I think the most important thing is to remember that correlation does not equal causation. Just because two things happen together
Yeah.
doesn't mean one causes the other. There might be other factors at play, those sneaky backdoor paths.
Right. Or even colliders.
And that's where our DAGs come in.
Exactly.
They can help us map out all those relationships, make sure we're
Yeah.
not jumping to conclusions.
It's like a mental checklist for critical thinking.
Our source material actually ends with a challenge for our listeners.
Oh.
They encourage us to think about a real-world question we're curious about and try to sketch out a DAG for it.
It's a great way to practice these concepts.
Yeah.
What variables might be involved?
Yeah.
How might they be connected?
Right.
Are there any potential backdoor paths or colliders lurking in the shadows?
It's like a mental puzzle.
Yeah.
It can help us see the world in a new light. So to our listeners, we challenge you, pick up a pen and paper, or maybe open up a drawing app
Yeah.
and give it a try. And if you're feeling brave, share your DAG creations with us. We'd love to see what you come up with. Until next time, happy dagging.